So it is 11:28. So we will start our session within a minute or 2 minutes. I think most of the participants have joined and some are joining. So it is 11:28. So we will start our 2 minutes. Okay. Okay, fine. Most of the participants have joined and some are joining. So it is 11:28. So we will start our 2 minutes.
Nisha, who is going to introduce?
Darshi sir.
Sir, first, yes, sir. Sir, Hema ma'am will first start the session and she will invite you to address the gathering. Start now. Okay, I think Hema ma'am, you can start now.
Yes, Emma, you can start up.
Am I audible now?
Yeah.
Okay. Good morning, dear participants. Head of the department, ASH, department in charge, math section, my colleagues, and today's eminent speaker, Professor Rajesh Jha. Today we are gathered here for the webinar to motivate first years. The topic of the webinar is the importance of mathematics for engineers. Now I request Dr. Mayank Dalal, head of the department ASH, to welcome the gathering.
Good morning to all of you. On behalf of Sarvajanik Education Society and Sarvajanik College of Engineering and Technology, as well as our principal and all the staff, I would like to welcome all of you for this full webinar, which has been designed by the Mathematics section of Applied Science and Humanities Department. I hope at the end of this 1.5 hour session and the discussion along with you can able to understand what is the importance of the mathematics. So I once again welcome all of you, including all the colleagues, all the staff members, my dear students who are new aspirants, okay, new engineers, going to be new engineers, and all my fellow colleagues. Once again, welcome you all. Emma, you can start up with. Emma, we couldn't be able to listen you.
Okay, thank you, sir. Now I request Dr. Rajesh Darji, department in charge, mathematics section, to give brief introduction of the eminent speaker, Dr. Rajesh Jha. Dr. Rajesh Darji has not joined.
He has joined, he has somehow left the meeting. Emma, do one thing. You can continue. You can introduce him. There is some connection.
As Mayank sir has told, Dr. Brajesh Jha is the assistant professor in PDPU. He has guided 3 PhD students. That means one has completed PhD.
Hello.
भैया राजेश is there.
आवाज आवे छे? Am I audible?
Yes, you are audible.
Yes, sir. So please give introduction of Brajesh sir, Dr. Brajesh Jha sir.
Okay, there is some internet issue. Okay, good morning everybody. Now today we are having with us Dr. Brijesh Kumar Jha from Pandit Deen Dayal Upadhyay University. He's a professor in the mathematics, and he is involved in research work, and he is going to deliver us his expertise towards the importance of mathematics in engineering. So I request Dr. Jha, please take floor and give your expertise to our students. Dr. Jha, please.
Thank you, sir. Good morning to all of you. First of all, I would like to thank the organizing committee, Mayank Dalal sir, Manisha ma'am, Emma ma'am, for inviting me for this interaction with the first year students who are going to not only join the engineering stream, they are going to develop the new area where they are going to work. So just I share my slide first. So is it visible to all of you?
Yes, sir. It is visible.
So in today's interaction, we are going to discuss about the importance of mathematics in engineering. So in our classroom, when we take the students in first year and second year as well, in each and every topic of the mathematics, we start with the application of that topic. So we give the overview of the topic related to the engineering. Suppose we are going to teach in mechanical engineering and we are teaching differential equations. So we give the overview of the differential equations in mechanical engineering. If we go for the chemical engineering, so we drive on the section accordingly. So it is very nice to interact with the beginners who have the background of mathematics, physics, and chemistry. So in this new journey, they have such stream, and no doubt with the help of physics, chemistry, and mathematics, they are going to develop their career as well. So first of all,
Just 1 minute. Emma, can you switch off your mic? Can you switch off your mic? Emma. You can continue, sir. You can continue. Sorry for disturbing.
So I start with this quote. In the long history of humankind, including animal kind too, those who learn to collaborate and improvise most effectively have prevailed. The Sir Charles Darwin have stated this statement, and we see we cannot move alone. We should move with the collaboration with all others also. So if I say the mathematics is the only one thing, definitely I will be wrong. If engineering is only one part, so again it is wrong. So when we talk about the engineering, it is a combination of mathematics, physics, somehow chemistry also.
Excuse me, sir.
That
Please
engineering.
Please put in slide slow-mo. It's not visible. Your presentation, please
Okay.
put in slide slow-mo mode.
Is it now?
No. Play slide slow, please.
Yeah, it is playing on my screen. That's why I was asking.
Okay, no problem.
Okay, just a minute. Just a minute. Is this slide visible now?
Now okay. Okay.
Okay, fine. So when we share in Google Meet, sometimes it says the PPT, sometimes the whole screen. So now it is whole screen is shared. So we were talking about man is a humankind. We should collaborate with each other. So what we do in the classroom also, whenever we teach mathematics in semester, we invite 2-3 engineering faculty as well, and they deliver how much times they want, 15 minutes, 30 minutes, maybe the 1 hour. It's depend on his interest. They deliver about the importance of mathematics in a specific branch of engineering. So that kind of collaboration, definitely it is a learning for us also, as well as the student also. So whenever we teach mathematics, we should talk about the importance of mathematics. So let's, for the beginners, those who are who have started the new journey. So engineering is quite different from the science. So what is science? Science always try to understand the nature, but the engineers try to make things that do not exist in nature. So this is basic difference between the pure scientists of the science background and those who have selected the engineering. So engineers always try to make things that do not exist in the nature. So engineers stress invention also, we can say. So it gives his idea in concrete term and designs some things that people can use. So what we understand here, that some things can be a device, gadget, material, method maybe. Engineers sometimes do the computing programming also, innovative experiments, new solutions to the problem, or improvement on what is existing. So these are the work of the engineers. So can we do this without the help of mathematics? Let's see in the upcoming slides. So since a design has to be concrete, it means it must have the geometry, dimension, and the characteristics numbers. So whenever we use the word geometry, dimension, and some numbers, definitely we should think about the mathematics. So almost all engineers working on new design find that they do not have all the needed information. So in the lack of information, what they do, they study mathematics, physics, chemistry, as well as biology and mechanics. So this is the work of engineer. If they go for the study of particular topic, they must have the background of good knowledge of mathematics, physics, and these all subjects. In the upcoming slides, I will tell you why mathematics is important in the engineering. So, engineers, sciences are born. In one sentence, if we say, engineering is the profession in which a knowledge of the mathematical and the natural science gained by study, experience, and practice is applied with the judgment to develop ways to utilize economically the materials and forces of nature for the benefit of mankind. So that way we understand the engineering and all about the engineers, what they are going to do, what they are going to learn in 4 years. So all about mathematics now. Mathematics has always been a tough subject to study, and the students are always struggling with a fear factor associated with mathematics. But dear students, if you are good in mathematics, that's why you have selected the engineering stream. So that fear factor is always for the others we may consider. So what we see, the practice makes a man perfect. I just edit this sentence. The good practice makes a man perfect. Hold truth in many typical tasks. It also hold true for study as well. Mathematics has been too complicated for the majority of the students. So if you want to learn mathematics, so you should have the good practice. Only one solution to learn mathematics. And if you are good in mathematics, definitely you are going to be good in engineering as well. So mathematics as primary subject in core and new engineering course is compulsory in worldwide engineering education. So whenever you have selected engineering, any stream, you should be strong in mathematics. So these are the several branches where mathematics are widely used. Without mathematics, it is better to sometimes interact with some engineering faculty also, how they are using mathematics in their research areas. So they will definitely tell you in detail in the 3rd and 4th year. And in that case, you will understand how it is useful. So in engineering mathematics, basically, what we study, linear algebra, differential equation is required, numerical method for the solution of differential equation and the partial differential equation, probability theory, statistics. These are the widely used in the computer engineering, ICT, electronics engineering, somehow in the data analysis in the mechanical, industrial as well, and the calculus. Calculus is the basic, we can say the basic mathematics of all engineering mathematics. Without calculus, we are not going to deal engineering. So whenever we say about the calculus in this part, so where we study about the engineering, we use the engineering mathematics, that is the chemical reactions, fluid dynamics from the mechanical engineering, theory of mechanics, thermodynamics, air compressor or electrical signaling as well also we include here, steam engineering. So few points I have given here where engineering mathematics you are going to use. To study first, suppose you are going to study about the fluid dynamics, you require engineering mathematics. So all about the base is always mathematics, and then you pursue your particular stream. So when would we talk about the calculus? I think in your first semester, somewhere maybe in the second semester, so first year included here, you will study about the function and relation, differentiation, integration, partial differentiation. These are the topics: vector calculus, matrix or matrix algebra. Some others are also, just like the Fourier series. In first year, somewhere in the second year, you study. So I will concentrate on the integration, differentiation, partial differentiation, matrix algebra, Fourier series. So that all combined, I will try to narrate one mathematical story where all the engineering branch will come, and you will see the different areas or examples related to engineering. So suppose we talk about the Fourier series. First of all, if I deliver here about the Fourier series, so it will not be good for the beginners, but graphically or by the figure we can understand about the Fourier series. So all of you know about equipment like fan, tube, many things that work on the AC, alternate current. So what happens if you use the cell, a battery, in the absence of electricity? You know, you have studied in the physics, the battery always generate the direct current. Our equipment work on alternate current and we have to use direct current. In that case, this inverter comes out, and this inverter also used in the solar panel as well, where you know these panels always generate the direct current, and that for the motors or inverter we go for the alternate current. So this is a good example of use of Fourier series, where direct current is converted in the form of alternate current. So at this stage, what we understand about the Fourier series. So whenever we require the oscillating pattern of a function, we apply the Fourier series on the function. By applying that Fourier series, our behavior of the function becomes the oscillatory. This is only the formula that you are going to study in detail. But here you can understand about the sine and cos, the sinusoidal function that we use here. By the combination of sine and cos, this behavior becomes the oscillatory. In detail, you will study in your class, but whenever we say the application of Fourier series, it is a good example. You always remember about the inverter. Now, suppose we talk about the integration, where what you have learned earlier about the integration, like area below the curve, volume of revolution, surface area you find, moment of inertia you have studied, and vector calculus also. In there also you have studied about the integration. Here I will talk for 5 to 10 minutes about the area below the curve, but in different manners. You know, area below the curve, you know the formula, integration of fx dx. But the thing is, if y is equal to fx is available, you will get the area below the curve. This figure you have studied in your 11th and 12th standard. But the thing is, if this y is equal to fx does not exist here, suppose I tell you to find the area of this region. Can we find using this formula, area below the curve? Definitely no. But we apply the same logic here as well, the area below the curve. So for this, what we do, just we draw a straight line in the middle of this figure, or any one area first we select. If we get the area of first any one figure, the another also we will get accordingly. It means what we have done here, we have divided this in the form of two parts, either in this way or maybe in this way you can get. So such kind of figure get the such kind of area. So what we do, we divide the whole region in the pieces of trapezoids, and we suppose that it has the same length, and these ordinates are assumed to be a straight line. So by combining this, suppose we have this kind of figure where this function is not known. In that case, what we do, we draw the straight line like h0, h1, h2, h3, h4, h5 you see here, but the difference is same. If difference is not same, there's another method that you will learn in your class. Here we consider the d is the same differences here. So what we see, y is equals to fx is not given. So what we see in the place of s0, you can write y0, y1, y2, y3, y4, y5, and yn. So different kind of trapezoids you can frame here. Now, suppose we have such kind of trapezoids. It has a two part, A1 and A2. The lower part is the rectangle, upper part is the triangle. So how we get the area of this trapezoidal? So it is, suppose this is the first line, y0. This is the second line, y1. The delta x is the length of, or base length we can say. And this distance we can frame as a y1 minus y0. So the basic mathematics we use here to find the area of trapezoidal. So it is, A is what? A1 plus A2. So what is the area of A1? A1 is your triangle, so it is half into base into height. And same way, it is the area of that rectangle. So by adding these two, del x, y0, when you add all this, it is going to be 1 by 2 del x, y0 plus y1. Same way, suppose we have given this y1, so that this figure will start from here. So by separating, I have shown you here the y1, y2, and the difference is y2 minus y1. Same way, the area of such kind of trapezoidal is A is what? A3 plus A4. And same way, the area of triangle, area of rectangle, that gives you 1 by 2 del x, y1 plus y2. Suppose we have the third trapezoidal. Again, it has a two part, A5 and A6. So it is going to be y2, y3. And finally, y3 minus y2, whether it is positive, negative, doesn't matter. And we get this result. So by combining all these three, we can extend the area here. By adding all these three, it is going to be the area of all A1, A2, A3, A4, A5, A6. So by adding all these three, what we get? It is 1 by 2 del x, y0 plus y3, and plus 2 times of y1, y2. So what we conclude in this formulation, if we do not have the function y is equals to fx, so what we think here, by drawing some straight line vertically, y0, y1, y2, y3, y4 up to yn, and we have the simple formulation, it is 1 by 2, the length, this is del x, equal interval, and addition of first and last vertical line, and addition of 2 times of rest of the vertical lines. By adding this, we will get the area. Definitely, you are not going to have the accurate area. Here, you will get the approximate areas, no doubt. So, for this purpose, what we do, here, we draw the more straight line between the straight lines. And your interval will be, in the place of d, it will be d by 2. So, by adding number of lines, you will get the area of such structures. So we have used the same process, area below the curve. It is defined in the same manner. So come to the next. Maybe you have studied in the chemistry, there is a chemical reaction. So what happens in the chemical reaction? A substance A that reacts with the substance B and makes the substance AB or C. With the rate of K1, it is the association rate. And if it is reversible, then it is going to be K2. It means from C, it is again subtracted in the form of A and B. I have taken the simple reaction A plus B is equals to C, but you can have the chain of reactions. So what we understand here, by having this reaction and applying some physical law, that is, suppose we are using here the law of mass action, it is going to be formulated in the form of a differential equation. So the law of mass action states here, the rate of the chemical reaction is directly proportional to the product of activities or concentration of the reactants. So it is based on the reaction rate and the concentration of these three substances A, B, C. Suppose we formulate here the rate of change in A, substance A. So it is going to be what? It is dA upon dt is equals to minus of K1 concentration of A, concentration of B, plus the rate of deassociation K2 and substance of C. Suppose we formulate for B also, it will have the in same manner. If we find the rate of change in C, you see here only the sign is changing. It is the reversal order. If K2 is not present, so K2 will be 0 and 1. So in this way, what I have tried to represent here, you know about the differential equation, you know about the chemical reaction, and in the chemical engineering, most of the time you study about the chemical reactions. So the mathematics, again here, the differential equation comes out. So whenever we go for the solution, we have to apply some methods. I'm not going in detail. Here I have shown here how the differential equation is framed in the chemical reactions. Now, later on, I will include this chemical reaction in the other part. Here, another example you can see the heat flow in the uniform rod. I use here uniform rod. In upcoming slides, we will see also if it is not uniform. So what will happen? So what we see, the heat flow or the heat equation follows from the physical law of conduction of heat, law of conduction of heat, and the conservation of energy. So these two laws, I hope so you have studied in your 11th and 12th standard physics. So according to the Fourier law, what happens? For an isotropic medium, the rate of flow of heat energy per unit area through a surface is proportional to the negative temperature gradient across it. So what we have the mathematics here, it is the negative temperature gradient, the vector calculus you can see here. So mathematically, what we see, it is the Q is equals to minus of K del T. So it's all about the temperature distribution in the rod. That you can elaborate with the mechanical engineering, maybe the others also. Here, the K is the thermal conductivity of the material. T is the temperature. T is depend on X, space and time. X we have taken if we are talking about one direction. If we include Y, then it will be the two-dimensional case. Q is what? Q is our vector field that represents the magnitude and direction of the heat flow at the point of X of space and time T. So by this Q, what we go for the next, if the medium is a tin rod of uniform section and material, the position is a single coordinate X. So in one direction we have assumed here, similarly we can go for the 2 or 3 dimension. Now the heat flow towards increasing X is a scalar field, Q is QXT that given in the last slide. And the gradient is an ordinary derivative with respect to the X. So Q is what? It is what? Derivative of temperature with respect to X with the constant minus K. Now, when we talk about the heat is also defined for the X and T. The function of two variable you will study in the calculus. So heat H be the internal heat energy per unit volume of the bar at each point in time. In the absence of heat energy generation from external to internal source, the rate of change in internal heat energy per unit per volume in the material that we calculate del H. And this del H upon del T is the proportional to the rate of change in its temperature, that is del T upon del T. So here, from the flux Q, gradient Q, it is del T upon del X. And here, del H upon del T is the proportional to del T upon del T. By including all these, what we see, del H upon del T is what? Equals to C rho del T upon del T. These are the proportional constant. Tell you what is it. So del H upon del T is what? Cp del T upon del T. Now, here C is the specific heat capacity. Rho is the density, that is the mass per unit volume of the material. Now, this derivation, we assume that the material has constant mass density and heat capacity through space as well as time. Because not only the dimension, we have also considered here the density is also uniform. Now we apply the conservation of law of conservation of energy. Here we can conclude that the rate at which heat accumulates at a given point x is equal to the derivative of the heat flow at the point here. So what we see, del H upon del T is what? C rho del T upon del T, and del H upon del T is what? It is del Q upon del X. Negative signs for high temperature to low temperature we are talking about, or left to right, you understand. So we use these two. Del H upon del T is what? It is C rho del T upon T, and Q is minus del dt upon dx. Is 2. Del T upon del T is going to be this, you can take this side, so it is 1 upon C rho del H upon del T. And this del H upon del T is what? Del Q upon del X minus form we can take here. So del T upon del T is what? Minus 1 upon Cp del Q upon del X. And this Q is here, you understand, Q is what? It is a minus K del T upon dt upon dx. So by including this, what we get here, del T upon del T is what? K upon C rho, second order derivative you see here. So by defining this, it is going to be del T upon del T is equal to K upon C rho del square T upon del X square. This is known as heat equation. Since we have talked about the temperature gradient and heat distribution, so it is known as heat equation. In the place of heat, if you think about the water or any other material, it will be known as diffusion equation. Here, alpha is what? K upon C rho. It is known as thermal diffusivity, or for other substance, we say it is diffusion coefficient. So we have started with the heat flow in a uniform road. It may be in one dimension, it may be in two dimension. In the place of heat or temperature, if we change the material, the same process, it is going to be delivered in the other branch of engineering. So finally, your heat or diffusion equation is what? Del T upon del T is equal to alpha del square T upon del X square. If I'm going fast, just let me know. I will try to deliver slow. So what we see, in the place of T, if we consider any C substance, C is what? C may be any other material you can think about. So if C is the chemical substance, so the chemical diffusion you can consider in the chemical engineering, spelling that. C is mass, it is in the mechanical engineering. C is the material. If it is material, that is related to civil engineering, fluid flow, related to mechanical and chemical as well, civil as well. If it is the ion flow, that we not only consider with the electrical engineering, we consider with the other biological part also that we are doing. I'm working on that areas, the electrical signaling. And the computer engineering also as well. For example, wireless sensor network. if we go for the wireless sensor network, we definitely study about the such kind of diffusion equation with the help of Kalman filtering. Now, here diffusion equation, it is given in the one direction part. So whenever we go for the solution of such kind of diffusion equation, we use, sometimes we can use Fourier series for the solution, Laplace transform as well, separation of variable, analytic methods we can apply here to get the solution. So whenever we go for the solution, again, you have to use a lot of mathematics behind this. But this diffusion process represent the problem, real world problem of the engineering. Now, suppose this diffusion equation we consider for the two-dimensional case. So in two-dimensional case, what will happen? Since it is in the form of x and y, in direction of x and y, so it will cover the rectangular dimension. So here also you can use the analytic method as well as the numerical method. For the solution of this part, if we have any irregularity in this part, so if it is not uniform, even though it is in the shape is uniform, but the material is not uniform, suppose the density is different, in that case, what we do, we subdivide this plate. Suppose you are talking about the temperature distribution through the plate. So in that case, and if the metal of the plate are different, it means its material property are different. So in that case, we cannot apply this solution to the whole plate. So that's why what we do, according to the nature of the plate, we have subdivided this, not only in this direction as well, you can subdivide. And as you know, you will learn about some such methods, how we apply this solution for this particular question. According to node, you will apply here, but I am not going in detail for the solution part. But when we use the solution, this equation will be converted in the form of system of equation. And which kind of system of equation? That is Ax is equals to B, where A is the matrix, square matrix. X is also the vector, column vector, and V is also the column matrix. So we study matrix algebra. You may ask where we study the matrix algebra. So this matrix algebra is used for the solution of system of equation. And this solution of system of equation is used as a part of the solution of this diffusion equation. And this diffusion equation where we can use, that I have shown you in the last slide. So that combination, we should understand how we use mathematics in the engineering. So you have to study the system of equation. You have to study about some matrix operation here, because it has a different way of solving this Ax is equals to B. Maybe you have studied in the 11th and 12th standard by operating A inverse, X is equals to A inverse V. So you will get the solution. So one solution you know here, and other methods that you will learn in the upcoming semester 1 or 2. Now, this is the rectangular area. Okay, so matrix algebra you will apply here, and this method is known as FDM, finite difference method you apply. Suppose your area of the process looks like that. So in such condition, you can always try to cover this area with the help of same rectangular region. Here you can see some part is out of the area covered and some additional part you have covered in this area. So if you apply same process in this region, so it will create some error in your solution. So other way, you can apply the circle or ellipse here. So you will convert this equation in the form of elliptical or circular by having some transformation. Again, some parts also missing or including the areas. This is also a way of getting the approximate solution. So in such case, what we see, we divide this whole region in our own way, like this, right? So by dividing this, because one thing, if it is uniform, but in such a manner, if it is not uniform, the material property are different. Again, same way, we have to subdivide the whole region. Here, in the finite difference method, you have the system of equation, but here, in this way, it is also going to convert it in the form of system of equations, but here you have to apply some integration as well. So I am not going in detail how will you solve it. So here, for this equation, you will transform this equation in the weak form by applying some integration part. And after that, when we solve this node, these subregions as well, you will have again system of equation. System of algebraic equation or system of differential equation, both you will get in the solution. Suppose del t upon del t, if you are included, so it will be system of algebraic equation. That system of linear equation that you have studied in your maybe the 8, 9, 10 standard. If it is del t upon del t is included, in both cases, it is going to be the system of differential equations. And again, system of differential equation, you have to solve you either using matrix algebra or other methods. One is finite element method. You may ask where we are going to study these things in semester 1 and 2. But dear students, you need to have linear matrix algebra, integration, differentiation, Taylor series, everything you require to get such kind of solutions. And such kind of solutions you are getting in your related to branch of engineering. These are some examples where we can see some location we see here. In the wireless sensor network, we use the finite element method and Kalman filtering to identify the location of this kind of mobiles, towers. So for the computer engineering students, you can go through the wireless sensor network where you can see such kind of mathematics, differential equations. Same diffusion equation is used, but there they not say the diffusion equation, but the equation is always parabolic nature they use, and according to that they apply the mathematics in wireless sensor network. Another example you may see, same wireless sensor network we say here, the load balancing routing is also applicable using the finite element method and the Kalman filtering. Here, analysis of dynamic of crack propagation using remeshing technique. So whenever we see the crack in the material, and crack in the material is a very wide area of study in civil engineering. The matters, whether it is related to the bridge, any topic you can select as a crack propagation. So crack propagation is used and studied with the help of mathematics. So without mathematics, you are not going to analyze such kind of, suppose we are talking about the life of the crack, suppose you are talking about the how it will spread accordingly. So all things you have to study with the help of mathematics. I am not saying mathematics is one and whole and soul. It is a combination of maths and engineering. So for engineers, mathematics is required. Somehow, being mathematics faculty, we also require engineering knowledge. at the last, I would like to end with this quote. A chemist who does not know mathematics is seriously handicapped. It is quoted by this scientist. And Kelvin says that, do not imagine that mathematics is hard and repulsive to common sense. It is merely the inner realization of common sense. Do not afraid from mathematics. If you are good in mathematics, definitely your engineering program will going to be at high level. You will learn much more things in engineering with the help of mathematics. So mathematics is not separate from engineering. It is a part of engineering. So if you include mathematics in your study, not only mathematics, I tell you physics as well as chemistry, it is going to be very, very interesting engineering program. What, in which area, which stream you have selected doesn't matter. So I would like to end with this slides. This is my YouTube channel. You can go through this for the mathematics. If you have any query, definitely ask.
Any query from the audience? From the candidates? Any query? You can ask any question related to the applications of mathematics in engineering. Announcement is there. The link for feedback is displayed in the chat box. So you please give your valuable feedback. All the candidates are requested to give the feedback about this program. Now, thank you very much, Brajesh sir, for your motivational talk. I'm sure that the knowledge you have shared will be very much useful to the participant in their respective field of study. I'm also very much thankful to our Honorable Principal Sir of SCET, Professor Dr. Hiren Patel Sir, to give the permission to organize this event. I'm very much thankful to our Head of the Department of ASH, Professor Mayank Dal Sir, also our Department in charge, Professor Dr. Rajesh Darji Sir, and all the faculty members of Maths Department for their throughout support to make this event successful. Last but not the least, I'm very much thankful to all the participants of this webinar to organize this event. Okay. So, if anyone from the audience can give any feedback right now or what they feel about this webinar. Okay, so with this, I think we can end this session. Daji sir, can we end this session? Hema ma'am.
Okay, if there is no query, then we can end. Darji sir?
Okay.
Okay.
So thank you, ma'am. Thank you all of you for inviting me. It was a nice interaction with all of you. And,
Yeah, same here, sir.
I hope so in future definitely we will have some interaction also. And for
Yes,
your
of course.
information, in January at PDPU we are organizing one STTP on solution of differential equation and its application. So all of you are most welcome in that event.
Yes, sir.
Thank you, ma'am.
Okay, sir. Thank you, sir. So with this, I think we end this session. All of you are requested again to fill up the feedback form. Okay. Thank you, all of you.
Thank you.
Okay.